Okay, the next section is binary shift. It's actually quite an easy section once you get the hang of it. In the exam you'll either be asked to shift a binary number to the left a number of places or to the right a number of places. It sounds stupid, but make sure that you know your left from your right. Don't sort of rush into this, actually have a think about it. So if you're given the binary value 1, 0, 1, 1, 0, 1, 1, 0, 1, and you are asked to do a shift 1 place to the left, what you have to do is you have to move all of these numbers 1 place to the left, and we would just disregard this number over here. So if we do that, we should have the number 1, 1, 0, 1, 1, 0, 1, and then we always put, because there's nothing up here to go down here, we always just add on a 0. Okay, that would be how you do a shift of 1 to the left. If we had another binary value, so 1, 1, 0, 1, 0, 0, 1, 1, and we needed to do a 1 place shift to the right, everything just moves 1 place to the right. Anything that's on the end just gets disregarded. So this 1 would come down here, so we would have 1, then we would have the 0, 0, 1, 0, 1, 1, but because now we're only left with 7, and we obviously need 8 bits in our byte, we just add a 0 onto the left hand side. So fairly easy to do a binary shift of 1 place, and to be honest it's just the same really if you're doing more than 1 place. So if we had the binary value 1, 1, 0, 1, 1, 1, 0, 0, and we needed to do a 2 place shift to the left, then it would be this value here that would go across 2 and then down to here. So it would be a 0, then the next number along, so 1, 1, 1, 0, 0, and obviously we've got nothing up here and up here to move down, so we just fill the space in with zeros. Whilst you're revising this, there are websites that you can use to check your workings out, but as long as you double check them, it shouldn't really be a problem. So the same would happen then obviously if we shifted it to the right. Okay, so here's one very quick example of that. So if we had 1, 0, 1, 1, 0, 0, 0, 1, and we needed to do a 2 place shift to the right, we would obviously be disregarding this one, and it would be this one that goes across 2 places and then down and becomes our first number. So 0, 0, 1, 1, 0, 1, and then we obviously fill up the last 2 places with zeros. 1, 2, 3, 4, 5, 6, 7, 8. Always make sure you check that you've got your byte complete when you're writing these out. Okay, so what we're actually doing when we're doing binary shift is we're either multiplying or dividing a binary number. If we are moving to the left, if we are shifting to the left, then what we're actually doing is we are multiplying a binary number. If we're moving to the right, then we're obviously dividing our binary number. And depending on the number of places that you shift will depend on what it is that you're dividing it by. So if you shift 1 place, then it's the equivalent of either timesing or multiplying, or dividing by 2. If you shift 2 places either direction, it's the equivalent of multiplying or dividing by 4. And you can probably see where this is going. 3 places is the equivalent of 8, and 4 places is the equivalent of 16, and so on and so forth. I really can't see them asking you to do any more than 1 or 2, to be honest, but as long as you know which one you've got to pick, if they ask you to divide a binary number or multiply a binary number, then it's just a case of shifting a different number of places. So this column here is the places that you shift, and this is what the factor that you're multiplying or dividing by.